Hi, everybody.
Hello.
Can you hear me? Can you see my screen? Yes. Everything
Yes.
okay. Okay, great. Okay, Tariq is here as well. Okay, so welcome to our first workshop related to relational databases. We will have 4 workshops in a line, and today our workshops will be based on the first chapter of your textbook about the ER diagrams. So the plan for today is first, say a pair of words about the databases again. We already mentioned the databases previously on previous lectures, previous workshops, but today a bit of words more about this. Then I will be happy to hear your questions about the chapter in the textbook. And then I will ask you some questions. And this list of questions is based on typical interview questions about the relational databases, and in particular, the ER diagrams. And of course, then we will have the workshop itself. We will do one exercise with me together, and then you will work in groups. I will divide you into 2 groups, and you will work, and you will try to understand the ER diagrams yourself. And then, of course, you will be returned to the main room in Zoom, and we will discuss your results. So this is the plan. And again, in the beginning of our module, a pair of words about the databases. You already read in the textbook that the databases is the very important part of any 3-tier application, and anyway, any application, not only 3-tier application, because any application should store the data somewhere, and any application cannot cannot work without data. The data could be stored not only in the relational databases, but in non-relational databases, in some file storage maybe, but anyway, relational databases is still the main popular thing in the applications. And just believe me that if you understand the relational theory, if you understand the relational databases, and if you can write queries to relational databases, it will be not so hard to understand the other types of databases, like NoSQL databases, for example. We will be focused on the databases during 4 workshops, but the databases information will be useful for you in the other modules. In the networks module, it is the light orange here, networks module, where you will learn how the data is going through the networks and how the data is going through databases as well. So the database could be in the network, so you will remember this material in the networks module. Then you will have the API module, and here, anyway, you will touch the database, I think, because some API methods can send data to the databases. So you will remember the databases here. Web UI as well, maybe you will touch a bit the databases. Then troubleshooting, very interesting module, as I already said. And you will understand how to define on which level of the application the bug is, including, of course, the databases. So you will remember the databases material here as well. And then when we will be going to the testing itself, here, testing types and levels, This module will touch the databases as well. Test documentation. We will write test cases and defects. And of course, we will write test cases and defects for checking database and for checking the integration between API and database, UI and database, or together, UI, API, and database. So again, we will be back to this material here. And requirements, customer requirements module. We will learn how to understand the databases requirements as well. Okay, so almost every module will touch the databases. In the test design as well, I think test cases will be connected with the database as well. Everywhere, almost everywhere. But now our goal is to understand how to read the information in the databases and how to manage the database during these 4 workshops. This is the very simple structure of our DB module. 1 workshop today is about the ER diagrams, and 3 workshops about the SQL, a special language to communicate with a database. And of course, today's material will be touched in these 3 workshops as well, because we cannot understand where to send our request if we don't know the ER diagram structure. So this is a bit of words about the module. And to be back to the previous workshop about the CV and about the fact that you have less than 120 days for your CV preparation. When this module is over, you could make this database theme black. Yeah. And then troubleshooting and levels of the application after the troubleshooting module. Okay, that was my introductory speech about the module. And now I'm ready for your questions regarding the textbook, the ER diagrams, all that stuff.
I have one question by the Beaver. How we can do on ER diagram, how we can do relation one-to-many.
I didn't catch your question clearly, sorry. Are you interested in the Beaver in particular? How to make the relation in Beaver? And what are you going to do in Beaver? Are you going to create your own database? Or
yes. No,
yes?
For ER diagram, I need to connect some particular table with another and create connection one-to-many.
One-to-many, so you should use keys in this case. Because in your main table, you will have the primary key, and in your table you want to connect with, you should have a foreign key. And this will be the relation one-to-many.
Okay, thank you.
So it will be automatically generated if you will create tables correctly with all that keys.
I think I have a question.
Yeah, sure.
So when I read the textbook chapters there, I saw one definition of normalization, how it works and everything, but it wasn't defined in particular what it is. It's like just optimization and stuff. So my question is, are we going to learn it a bit later, or is it just for our self-education in the future? How normalization works and stuff.
Yes, thank you for the question. Actually, it depends on you. If you want me to include this material to the course, I can do it. It was included later in the course, but for some groups, the material was pretty hard, and I excluded it from the course and just state the main information about normalization. But if you want to know more about normal forms, I could include it to the course. I could find the material for you. I could give you some links, some material to read, because this is interesting, and this is not so, basic material, because it is rather for middle to senior level of understanding the databases. But if you are so smart and you're so proactive and so, so curious, I can include it to the course. So to be brief, the normalization is a step-by-step process of how to optimize the managing of the databases, how to optimize the data in the databases to make the communication with database faster. Because the more optimizedly we will store the data in the database, the faster our application will work with the database. Because every time we try to get some information from the database or put some information to the database, every time we start searching through the database where to put, where this table is, where should we get this information, in which tables this information about some object is stored. And if everything is stored correctly, we will get the information fast. If not, we will go through the database, we will search in one place, in another place, and then in third place, and then collect everything together, and then think about how to organize this different parts of information, different pieces of information from different parts of the database. And okay, if we want to get one little piece of the information from the database, we will not notice this speed, that the speed is slower. But if we are talking about some huge amount of data, some big data or something, this optimization could play a role, because we will notice this slowing. And that's why we need this optimization.
Okay, so basically it helps, oh, sorry for interrupting.
Yeah, sure, please.
So basically normalization helps for databases with a lot of information, right? So if we don't have a lot of tables, so it won't be necessary, right?
I cannot say that it won't be necessary at all, because even if we have a small amount of tables, it is better to organize the database faster, normalize it, because now we have a small amount of tables, for example, but if our application will grow up, if we will need more and more objects to store in the database, we will need more tables, and it is better to start from normalization from the very beginning.
Okay, got it. Thank you.
Thank you for the question. Yeah. No more questions. Am I right? I'm right. Okay. Then I have some questions for you to check how the material is put to your heads, to your minds. Who can list me the tasks of a tester that require knowledge of databases? Why do we need this knowledge?
I can answer.
Yeah, please.
So we work with the application, and if we have we should find data and for a test. So that's why we need knowledge of databases.
Okay.
As I remember, remove some data from databases and look what happens. To make such tests, we need databases too, and actually, I don't remember more.
Okay.
I need to refresh my.
Okay.
knowledge.
You mentioned correct cases. Maybe somebody wants to add something.
Oh, I said remove, then probably to add.
Yes.
Seems
yes.
pretty
Probably.
logical.
Probably,
Find
yeah.
and add and remove. And
Yes. Find
something
that.
else.
Okay. Maybe some example.
It's just an example that we had in the textbook. So we have a students tables, teachers and exams. So if we want to find some specific exam, so we can use the database, or if you want to add the subject, we also can use the database, or if you don't have any teachers, we don't need them, we can just remove it, and that's it.
Yeah. Good. Okay, thank you. And for example, you add something from the UI, your test and application. For example, our educational application that you will see during the whole course, that booking some not real tickets, but some virtual tickets. And if you add a passenger, for example, from UI, you could need to check if this passenger is really in the database, because you, for example, added some passenger from UI, and you see that this passenger didn't add from the UI, and your purpose is to check where the defect is. Is it because of some UI issue? Is it because of some API issue, or because of some database issue? So you go to the database and you check if this passenger is added or not to the database. This is your regular task as a tester. Okay. The next question about the Excel. Maybe I will start some Holyvar, but I want to start it actually. Is Excel or Google Sheets, choose any of these, good for data storage? Maybe some cases when it is good, when it is enough, some cases when it is not enough to store data.
Well, I can answer. I can start at least. So as for me, since I work a lot with Excel tables, for me, it's one of the most useful application on the desktops. But as far as I started to learn that, yes, we have some negative features in that. So if you want to like define something or make some groups on everything. So there are a lot of things that we should do it manually still. And I think it's one of the main problem for Excel. So it works a bit slower than in databases that can find any information in a blink of an eye. So I think one of the great feature for databases is like the speed. And it's useful if you work not with a lot of information and you have to make some tables really fast and make some decisions and results.
Yes, you're right, absolutely. Somebody else maybe?
I have nothing to add. Sorry.
Okay.
I know only the short answer that Excel is slower than databases, and Anastasia explained it very well. So.
And why is it slower than database? Why so?
I guess because only the data stores in some sheets, 1 to 10, and it's too hard to find it and extract it.
Okay.
Maybe UI makes it a bit slower.
Could be, but we have just talked about the data optimization in the database. Is the data optimized in Excel? Typically, I can guess that there are a lot of different cases. It's maybe data optimization, but typically in typical data sheet, Excel sheet, Google sheet.
Maybe in Excel we have sometimes many duplicate information.
Yes. Yes.
And it can be optimized only online if you have Excel online, Google tables and stuff. But if you have Excel only on my desktop, I cannot optimize it and nobody can. So if you want to know some new information, I should find it somewhere else or just should add by myself. So it takes a lot of time to do this.
Okay. Okay. So let's go to the next question. Thank you very much, everybody. Let's stop the holy war. So the next question is connected to the previous one. Why do we need to optimize data storage? I already answered it, but maybe somebody could add something to my long speech. Why it is needed? If we are not talking about the speed, it is obvious that the speed is faster when the data is optimized. What else? What do you think?
More convenience, maybe.
Convenient to do what?
To find data to do what you need to do. Remove to add. So on.
Okay, to find data. This is the one reason. The first reason. Any other reasons? Alexander,
maybe optimization will help us to make less mistakes in in search, maybe some information.
Okay. The second
Also,
reason, okay.
Actually,
maybe something else.
When you add information, you less likely to make mistakes than when you type in names or just type an ID, you're less likely to make a mistake, I think.
Okay. Okay, you all are thinking about getting information, about making mistakes, but you didn't remember one more reason. I will give you a tip. Maybe you will remember this, or maybe you will just find this reason. So this database from the example from the textbook with students and mentors and teachers. So let's define that. Let's imagine that we have the Excel sheets or Google Sheets instead of relational database, and the information is not optimized, and we have the information about students in different places, for example. So, and for example, the information about the last name of students in different places, and we should change this information in different places. And imagine the situation when we have a student, a girl, who got married during the studying, and she changed the last name. And she brought some paper to the university with this information that please change my last name in all the documents because I got married and now my last name is like that. So you should go to all the tables on all the sheets in the Google Sheet and change her last name in different places, in 10 places or maybe even more. But if you have a relational database, you have this last name in the only one place. So you should just go to this one place and change this last name in one place. And everything will be changed automatically. So compare the time that you will spend for this operation if you have normally optimized relational database, or you have the sheets with the information placed everywhere, and you first should find this information and then change this information in different places. Okay, let's go to the next question. How is data stored in the database? What do we have in the database? Where is the data stored?
Tables.
In cells.
Tables and cells in the tables. Okay.
I mean,
okay, that was an easy question. How do we join different tables? What types of relations do you know?
Is it one-to-one relationship? Yes. One-to-many and many-to-many, of course.
Okay. What is the difference between these types? Why do we need different types? Okay, let's think from real examples, from the real world. Who can give me an example of one-to-one relationship?
To buy something specific and to give the money, is it relatable? Just give some money and
no,
give...
because typically different people, several people could buy something specific. If it is not like one example of some dress.
One person can have only one passport. I mean,
passport is not
one,
a good
it's-
example because
in
I
one
have
country.
three passports, for
Yeah, I have
example, in
two.
my life. And you said, but yes, you are thinking in the right direction, but not passport.
Maybe I don't know how to say it in English.
In an end,
Book ID.
INN, yes, INN, yes. INN is the unique thing. And one person can have only one INN, and it is not changed. Never, yes. If we are talking about passport, it could be changed, and a person can have different citizenships with different passports, but yes, INN is the unique. Okay, one-to-one. What about one-to-many?
One person, one buyer can buy a lot of
Stuff, things, and something else.
yes.
Mm-mm.
I forgot the word.
It's not one-to-many because one buyer can buy different things, but everything could be bought but by several buyers. It is not one-to-many.
Well, this is example from our learning database. One flight can have only one plane.
Okay. But we are talking about one-to-many now. What about one-to-many?
No, that's one plane can have more than one flight.
Yeah. This is a good example. Yes, one plane can fly different by different flights to different cities. Yes, this is from our database. What about the real life? One person, several, what?
can we add, for example, several bank accounts?
Yes, good example. Several bank
passports.
accounts, but one bank accounts cannot have several owners. Yeah, so we have
Several passports. So
several passports. Yes, pure one-to-many relationship. One person, several passports. One person, several bank accounts, but a passport cannot be related to several people. One bank account cannot be related to several people. So we have one-to-many relationship. Okay, and many-to-many. You already gave me an example, Talib.
about
With
the customer and I don't know.
order or stuff,
Yeah.
or
Yeah. I
object
forgot the word.
that bought. Yeah, okay, it's okay. So customer order, yeah, one customer
Yes.
can have
A few
different
orders.
Okay, but not an order, some product,
Yeah.
customer product. Of course, order has some unique number, and it is one-to-many. Customer product, one customer can buy several products, and one product can be bought by several customers. Yes, okay. Okay, seems that everybody understood this topic. Am I right? Alexander, Arina?
Yes.
I
Yeah,
didn't
yes,
hear you.
yes.
Okay, great. And the last question is data types. What data types do you know? And why do we need different types, different data types?
You mean string, numeric, and
Yeah, I mean that.
and I forget third.
Okay, let's start from the second question. Why do we need different data types?
To describe different objects.
For
To
example,
save memory, maybe.
save memory, yes. Excellent.
And for
Irina, thank you.
convenience.
To normalize our database.
Normalize the database, yes. It's not normalization, but this is kind of optimization,
Maybe
yes.
Optimize.
Yeah, okay. And operations with data, yes. Of course, it is impossible to operate to sum, for example, string and the number. So you can do it physically, but the result will not be the one you expect. So it is better to distinguish different data types. Okay. So what data types do you know?
I remember varchar, and char, it's about text. And integer, it's for numbers, and data and time, or data time.
Yeah. Okay, correct.
Flow.
It's not, no, that's not all. You forget about one.
No, it's all what I remember now.
Okay, yeah, sure. One more. Okay, not one more. We have more types, but not all of them are mentioned in the textbook. So please remember one more.
Floats. Like for the numbers that have I don't know what to say, floating point number.
Floating, yes, okay, floating. And one more.
Boolean.
Boolean, yeah. What is that, Boolean?
It's like true or false, 0 or 1, I don't know.
Just to be on the same page, could you give me an example of some Boolean type from the real life or from applications maybe? How does it look like, this Boolean, yes or no?
Maybe the order is spade or not, maybe.
Maybe light switch.
Light switch, yes. Yes, this is from the real life. From the application, how will it look like in the application, that Boolean type?
Maybe it's like connecting to VPN, for example, to switch.
Yes, yes, but if we are talking about some controls, how will it look like in the application typically?
On or off video, for example.
Yes, so any checkbox in the application typically is a Boolean type in the database. I have read the document. So I don't know. I want to get emails from the company with ads. Yes or no? I'm a doubt. Yes or no? So any checkbox in the application is typically a Boolean type in the database. Okay. Any questions here? Just to be sure that everybody understands the material. Nobody wants to have some additional explanation from me. Okay, seems that yes, everybody understands the material. Now it's time to train that knowledge. So you have the knowledge, and this is the plan. How will we train this? Your material was about the ER diagrams, was about the very basic things regarding the database. And I have 3 ER diagrams for you. We will start from the ER diagram together, and we will try to understand the ER diagram together. And then you will be divided into 2 groups. We have only 5 people today. Okay, 2 people in one group and 3 people in another one. Pair and group. And each one will try to understand the diagram. And then we will be back here in the main room, and discuss the results from each group together. So this is the plan for the rest of our today's lesson. And let's start from the first one. Is it visible?
Not
I
at all.
wouldn't say so.
Yeah.
No.
Oh, yeah,
It
that's
is
okay.
better.
A little bit better.
Okay. Okay, so this. Sorry. Yeah. Okay, everything is good. So this is your typical task as testers to manage with the ER diagram. So if you are new for the project, you just came to the project, and this project has a relational database, and you have access to this database, at least read-only access to the database. Your first task is to understand the structure of the database. What objects do we have in the database? How these objects are related to each other? What relationships do we have? Why so? And maybe something needs more optimization. You, as tester, can assess the database structure and can give some advices. Why not? You are an engineer and you can do it. So, first, the simplest question. Who can tell me what is it about, this database?
It's about hockey.
It's about hockey. Okay. And in particular, what do we have here? What objects? And what information is stored here? What do you think?
Information about the games.
Games, okay. Okay, hockey games.
Games, user, team, about every user. I mean, who play, I think.
Mm-hmm. Okay. Okay, okay.
Game score. Round statistics.
Mm-hmm. Okay, let's take some table. For example, okay, let's start from something more simple. Something more simple. Hockey team player. What is it about? To what is it related, and what information do we have here? Hockey team player.
About person who play in this team, ID. Hockey. What is it? I don't see.
Okay, so what fields do we have here?
ID.
ID.
And second one, I don't.
Sorry for interrupting, Arina. How could we call this ID?
I think it's a primary key.
Primary key, yeah, absolutely. This is a primary key of a player. Then we have what?
It's not visible for me. Team
Hockey
lead.
team ID.
Hockey team ID.
Hockey team ID.
Okay. What is it about, and why do we need it here?
I think it's foreign key.
And
it's a relation for hockey team, maybe another table.
Okay.
Yes. And first name, it's just information about team player. Last name, jersey number, and position.
Yes, okay.
Without any ID.
Without any
key.
So,
yes.
So all this information is the specific information about this player. First, last name, jersey number. I don't know what does it mean in a real life. Maybe somebody who plays hockey can tell me what does it mean, jersey number. Some number of team player. Maybe inside the team, I don't know. And the position, I think the position on the field. This is about it. Okay, so Arina, you're absolutely right that the hockey team ID is related to the hockey team. And what relationship do we have here?
I think it's many to one-to-many.
One-to-many, yes, absolutely right. In one team, we can have many players, but one player cannot be related to different teams. At least in this application, in this database, it cannot be. Okay, so the hockey team ID, name, logo. What does this mean? This relationship from hockey game to the hockey team.
Many to many.
Yes, I think.
Many to many. What is missed here?
Hockey game ID, I think.
Hockey game ID. Hockey game ID is not missed because we have it in the hockey game table.
Hockey
we
team
have the
ID.
primary key.
Okay.
Hockey team ID is missed, I guess.
Hockey team ID is not missed. In the hockey team table, we have the hockey team ID. Just an ID in the table. Here we have many-to-many relationship. What should be?
Another table with primary key.
Yes, Arina. absolutely right. We should have another table here, but the architecture of this database decided that it will work without it, but it is not according to the rights of database optimization. Okay. Anyway, we have many-to-many relationship here, and how the hockey game is related to hockey team.
By ID, team ID.
Team ID. How many team IDs do we have in the hockey game?
2.
2, yes. What does it mean if we are talking about the database?
So we have foreign keys. I don't know. 2 foreign keys.
We have 2 foreign keys, yes. And what could you say about these 2 foreign keys? Alexander? Go ahead.
No, I think there's 2 foreign keys from the one.
Yes,
Can you
yes,
hear
yes, yes. Yes, we can hear you, and you are thinking in the right direction. Please go ahead.
What should I say more?
So
These 2 IDs from the one table.
yes, yes.
And we should differentiate 2 teams, who guest, who home. I think that's why we have 2 IDs from one table.
No, this is not the reason. But you thought correctly that we have 2 foreign keys related to one table. So we connected 2 tables 2 times. So that hockey game is connected with the hockey team by by team 1 ID and by team 2 ID 2 times. And this is a normal situation. Maybe somebody already opened our educational database and could tell me where you have seen the same situation in this database.
In the flight table.
Yes, and what IDs do we have there?
One plane have 1 departure and 1 something else.
Not plane, airport.
Airport,
Not plane,
yes.
not plane, but yes, 1 flight.
My flight, yes.
Flight has arrival airport and departure airport ID. And both airports ID are connected to the airport table. Yeah. So that could be, yes. And here we have hockey game, and if we have a hockey game, probably 2 teams should be in the hockey game. Otherwise, it doesn't make sense to start the game if we have only 1 team. Yes. And that's why each hockey game is related to hockey team table 2 times. Okay, interesting situation. And now game scores the same. Team 1 score, team 2 score is related to the hockey game.
Yes, but it's just one primary key and one too many. It's super easy.
Yeah, it's strange a bit. Yeah,
Yes.
it's strange a bit. Team 1 score, team 2 score. But okay. No foreign keys. Maybe no, the round ID is it's not about it. Strange relationship, very strange. But you should be ready for this as well. Okay. What else? Round statistics and the playoff round. How that two tables are related to each other.
Here's a question, please.
And how it should be related.
It's also weird because in round statistics, we have a lot of IDs and we don't have any tables for it. So goal leaders ID, assist leaders ID and stuff, but we don't have any keys to this information. So it's also weird. And if you see a playoff round, we don't have any information about it also.
Yeah. And how is it better to really to have relations here? What could you propose?
To add tables consist of information that enlisted in round statistics, I guess. So, and connect from round statistics to, for example, goal leaders, and from goal leaders to playoff rounds. So maybe it will work like this better. And for any other situation, it could also work like this.
Okay. So if we are talking about playoff round table, we have team 1 ID, team 2 ID. To what table it is better to connect this playoff round? If you have that team 1 and team 2 ID.
Hockey team.
Hockey team, yes, it will be more optimized because now it is connected to hockey game, and probably that team ID 1 and team ID 2 are the same in hockey game table and playoff round table, yes, but it is like not optimized table. It is not normalized database because we have practically we have the same information in two tables here. Yeah, and it is better to connect with the hockey team, yes. And around statistics, Anastasia was absolutely right about this because we have that IDs and we don't have any descriptive tables with the information about that all that objects. We have only IDs, and we have no idea where to find the description of these objects. So it seems like not optimized table, not very much optimized. Something is good, something is weird here, and some tables are missed. So why I did gave you this strange table? Because don't think that you as testers will have ideal database in your real life, because not all the companies could allow them good data analysts, good data engineers who will create an ideal database for you. And you should understand that you should work with the database that you have. And you should be able to find some gaps, some places to improve in the database, and you should be able to advise your developers team how to improve, how to optimize the database, you as an engineer. So we have that strange table. Any questions here?
Just what should we do next?
Yeah. Please, I will give you 2 minutes to dig deeper to this strange database and to find other gaps. It is very interesting, actually. So
There are a lot of tables that I'm missing.
yes. If we are talking about all that objects information, goal leaders, assist leader, penalty leader, and all that stuff, yes, everything is missed here. But
and we have information one more time: team 1 score and team 2 score in user score. What is peaks maybe. One more time, it's abnormal, I think. Because we have this information in game scores table.
Yes. And how to optimize it here?
Delete it.
Delete it, but what instead? We need this information here in this table, and we can get it from some other table.
Yes,
and
here with ID, I think, and
yes.
have a relation with another table. Without any duplicate this information.
Yes, but actually, we have the foreign key here. But we have
foreign key and ID key, maybe no primary key in a god.
Okay, we have the primary key here, ID, and what foreign key will help us to get the information?
Good
about
question.
Course. We have it here already. Who can tell me?
It's the user ID.
No, user ID is about the user, not about the scores.
Hockey game ID.
Hockey game ID, yes, exactly. We have the hockey game ID, and can get the information from game scores table about the score. If we
Okay.
have the hockey game ID, we can go to this game scores. If this relationship will lead to game scores, not the hockey game. Yeah, or maybe to the hockey game, then to game scores. It could be a transition, yeah. From user score picks by hockey game ID, we go to hockey game. And in the hockey game, if we will have the foreign key to game scores, we could get the information from game scores. Did you catch my my idea?
I hope.
Yes.
So, if in the hockey game we will have the foreign key that will lead to game scores, from user score picks, we can get the hockey game, and from the hockey game, the game scores. So we can get the game, the scores. And practically in the user score picks, team 1 score, team 2 scores, score is the spare information. We don't need it here. Okay. What is interesting here more? User info, round 1 points, round 2 points, round 3 points, round 4 points. Okay, 4 rounds. And how to optimize it? How to optimize that 4 rounds in one table?
Create another table with rounds.
With rounds, yes. And what will be the relationship between user info and rounds in this case?
Many to one?
No.
No.
1-to-1.
No, we have okay, from this table we can understand that our user participated in 4 rounds. So 1 user, several rounds. How many users in 1 round? Many, yes. So what relationship do we have?
Many.
Many to one.
No. No, one more attempt. Okay, again. In the user info, we have how many rounds?
4.
4. So several.
Mhm.
1 user, several rounds. 1 round, several users. So user, round. What is the relationship?
Many to many.
Many to many, absolutely, Alexander. So to store this information and optimize this storage, what should we have?
We should create another table.
Yes, 1 or how many tables?
Well, at least 1 for the rounds where we can add information about round 1, round 2, and etc., and put a foreign key which leads to user info. So it's 1 table.
But we have many to many relationship.
Yeah.
Typically, what should we have if we have 2 objects with many to many relationship?
We have to create another table.
Yes, absolutely.
With foreign keys. or to
with foreign
this
keys,
table?
yes. This is it. This is what I expect from you. So to optimize it, we will have user info table, rounds table, and between user info and rounds, we will have some auxiliary table, additional table with user ID and round ID. And this will be the way how to make this database faster and how to optimize the information. And okay, we will have that user rounds. I don't know, again, maybe it could be only 4 rounds in hockey. I don't know. I'm not a specialist. But if, for example, the rules will be changed and now we will have 5 rounds, for example, not 4 rounds or 8 rounds instead, we will just add more lines or remove some lines from this auxiliary table, and that's all. And everything will work. So it will be a manual, a minimal update of the database. Okay. So, any other questions about this? Or we could go to the next task. No questions. Okay. So let me remove this. And we have two more things. This is for group 1. I will just send you the link. Of course, you will work in groups. And it will be better to have the diagram opened your local machine. I will send you. This is the first link to the picture, and this is for group 2. Group 2 is here. So, this is the ER shopping, and this is the bookstore. Okay, please open your Zoom chat and check that you can open.
I don't have rights.
Yeah, I don't have access.
Okay, let me give you the rights. And same here. Done. Please check again. Should be opened now.
First one is yes, second one, no.
Yeah, bookstore doesn't open.
Like that. How about now?
Still no.
No.
That's strange. Well, should be opened. Because I gave you the rights. Okay, if the bookstore cannot be opened, everybody could be the same group, maybe. And we will discuss that ER shopping. So I will not create the breakout room then, and just will leave you for some, I don't know, 15 minutes, for example. Please open this this ER diagram, discuss what is it about, how to optimize it better, maybe what primary foreign keys do we have, what strange things do we have here. Let's discuss together. So you will discuss together. I will hear your discussion, hear your results in 15 minutes. And then I will share the bookstore diagram, and we will try to discuss it together in the end of our today's lesson, today's workshop. Okay?
Okay.
Okay. So 15 minutes, guys. I will leave you for 15 minutes, and please, in 15 minutes, show me the result of your discussion. Okay?
Okay.
Okay. Thank you.
So. Well, who starts?
Give us some time to read it first. Okay, I can start, I think. And my first question is about the difference between PK and FK. I don't see any definitions.
Primary key,
Primary key.
foreign key.
Okay. I thought it's something with to buy something. Now makes sense.
I have a question about the relationship between categories and customers. It's one to many.
I think it's many. It's supposed to be many to many because we have a lot of categories and we have a lot of customers.
The same with products, many to many.
So yeah, so we have to add some table between categories and customers, as we see, as should be necessary or not, and between products as well.
Yes.
Wait, why? Sorry. Understand.
So it starts with the customers, because the customers are in the center, and they're the answers to many other tables, so shopping order, deliveries and stuff. So they have a lot of keys between this table and between each other. So I think we should focus on that and then go to any other tables and see what the problem. And as you can see in the transaction reports, we have a lot of keys, but we have only one connection to the products. So I think it's also, and to shopping orders. So I think it's a bit weird. So we can add something else there.
I don't really understand why in payment we have category ID as a foreign key.
Yeah, and it's not connected to the categories itself. So it's just connected to customers and then to categories. So it's like two steps.
It should connect with customer ID. And
I think that payment ID should not be in transaction reports.
Sorry, payment shouldn't be what?
In table transaction reports, it shouldn't be there because it already has this in payments table. Why do we need additional payment ID?
Yeah,
if it already has.
So yeah, I also think so.
It's the foreign key.
Foreign key, but it's not
double
connected.
information.
It's not connected.
Foreign key
with,
for what? Foreign key for what? Payment ID.
Yeah, that's what I told you. Transaction records has a lot of keys, but it's not connected to a lot of things. Arina, do you have something to add?
No. So many mistakes and oh my God.
I didn't see the purpose of having the transaction record table. So if someone can explain it to me, because it just summarizes all of the information that we have, right? And that's it. So it doesn't show any new information here.
So
Because we have in the transaction record table, we just have ID, and nothing new. So it just summarized. So why do we need this?
And we don't see relation between transaction and deliveries.
Yeah. Yes.
Because if we pay for something, I want to get it.
Yeah, makes sense. So yeah, if we connect these two, probably the transaction record table makes sense. But for now, as you can see, just nothing new appears in this table. So if we connect deliveries and transaction record tables, so probably it would help.
What kind of relationship without between seller and product? Many to many?
yes.
Well, it's written not sellers, so
Seller.
yeah, probably it's one too many. Yeah. Probably we're talking only about one shop, not about shops, different ones.
we have seller ID and its name and so on. Probably it's a lot of sellers. So
yeah, I also started to think because we have here seller ID, but no,
the application.
Everything is so messed up. Okay.
I I'm not really sure that seller has a few products have
Why?
sellers.
No, I think we have a lot of products. It's like a store. You go to the store and see a lot of stuff like breads, I don't know, cucumbers and stuff. So there are a lot of products.
Okay.
So yeah, I don't understand what's the true. So we have only one seller or like a lot of.
Do you think the deliveries table should have order ID?
What should it, what? Can you repeat?
The deliveries table should have order ID.
Of course, of course.
And we don't have, do we have like
Yeah.
a table of orders? We don't have.
In a deliveries table, we have only customer ID and the date.
Yeah, but we don't have order, right?
Yeah.
Just IDs and stuff. So we don't have a specific table for it. So I think we need it. And if we create another table with orders, we don't have to put a lot of information in different tables, like in shopping order, or like, oh no, we have shopping order. Oh, my bad. Okay, so we have already. So we have to connect shopping order table and deliveries.
Yeah.
Through
Yeah.
foreign key.
It's foreign key, right? Yes. So what's the key? Not key, but short order and deliveries. It's like many to many, right? Or just one order, one delivery. It's one to one.
One order can help.
No, one order, one delivery.
Yeah.
Why?
Okay, it's one to one. Okay.
One to one. Seems so.
I can do many shopping orders in one delivery.
Yes, I think it's normal situation.
But well, according to the real life, we also can have a lot of deliveries and a lot of orders. So for example, if I use, I don't know, Ozon or something else, I can just create a lot of orders from different dates of delivery. So it's also many to many. I think it depends. So probably, yeah, we have a lot of orders, but only one delivery, and we have a lot of deliveries for many orders.
It depends on shop.
Yeah.
Yes.
Okay. Guys.
Hello.
Hello. Yes. Hello again.
Hello.
So, what is your result? Who can describe me this schema? Who can describe me what has happened here? What is strange?
Here, everything is so messed up. We have a definition. Yes, and there are a lot of things that should be corrected or added because yeah, a lot of mistakes here. So yeah, I think I can start and other guys can add something else. So first of all, we have a lot of misunderstandings between I don't know, we can start from the connection between deliveries and the shopping order. So basically it tells the story about like buying and selling. So it's like stores and the customers relationships here. So, and if we want to start from the deliveries and shopping orders, so we don't have any connection between these two tables, but we need it because it's connected. It's like a foreign key to each other, and we have. Yeah, I think it should be connected because without deliveries, we don't have any orders. Orders cannot be delivered and stuff. I think it should be connected. And to put, for example, in the deliveries like order ID and yeah, and connect. But we couldn't decide it yet what connection should be, like one to many or many to many, because we have different situations. So I don't think we can like result according to this situation.
So what situations?
So we didn't decide yet which connection it's supposed to be.
Yeah. I got it. My question is, what situations could we have between order and delivery? And let's think together what relationship should be here. How many deliveries could have one order?
A lot. It can be one, but if you have one order, but in one
actually,
order, two or three, yeah.
I think that one order can have one delivered. I mean that you can deliver one order just once.
Yes. Okay, let's discuss what the order is. Order is an object that has unique number, and order means that a customer ordered some set of products and wants to have the products delivered to some particular address.
Yeah,
like you bought something in e-shop and you set your address in the order. So order is something unique.
But can I discuss a little? So
please.
For example, if I order something, I don't know, in some marketplaces and I have a lot of stuff and I just decided to buy it at once, so I buy it and I have an order number, but on the marketplace it's written that part of it will be delivered tomorrow and the other
partial delivery.
Yes, so it's different
Mm-hmm.
deliveries, so that's what I'm talking about.
It is a partial delivery, and we should think about how to store this information about about one order or different orders. Probably it will be one order with a unique number and the partial delivery. And in this case, yes, we should have different deliveries. So not should have, we may have different deliveries for one order. And yes, in this case, we should have a foreign key in deliveries table that is related to the order number, the order ID. Yes, if it is about a partial delivery. Yeah, but one delivery in this case cannot be for different orders, I think. What do you think?
Yeah, that makes sense.
So what relationship is the most appropriate here in this case? One to many, yeah. So one order could have different deliveries, several deliveries, but one delivery cannot be related to different orders. And that's why we will have one-to-many. Yeah, exactly. Okay. So we should have the relationship between shopping order and deliveries. What else? Who wants to proceed?
Also, we didn't understand about the transaction reports table. It has only foreign keys and no more information. So all the information is duplicated from other tables.
Yes, but it is that auxiliary table that connected all that stuff together. So customer, the order ID, product ID, and payment ID. And through this table, we could get any information.
Yeah, but why do we connect it to I'm sorry,
I think
forgot that.
say that we have a lot of foreign keys, but we don't have any connections. So we just have two of them, just transaction connected to products and transaction connected to shopping order, while we have a lot of keys in this, so we have to create more connections.
Yes, this is
that
clear.
was my second thought. Yeah. Thank you.
Product category. Okay, let's begin from understanding what is it about, that transaction wrappers. So connect customer ID with order ID, with product ID, and with payment ID, and all that should be connected to each other, should be related to each other with the relationship many-to-many. Let's check.
It's not connected with payment table at all.
Yes, that's what Nastasia said. Yeah. We don't have all the connections here. We have only two, and the others are skipped. So let's check. All that objects should be related to each other with a many-to-many relationship, like except report ID, of course. Report ID is about reporting all that things. Customer ID and order ID. Is it many-to-many?
Customer to order, right?
Yeah, customer to order. Is it many-to-many?
No.
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 Why?
Well, one person can have a lot of orders.
Okay.
So it's one-to-many.
One-to-many.
But orders cannot belong. One order cannot belong to many customers.
Cannot belong to different customers. Yes, this is one-to-many.
I have a question about the categories and customers relationship. I don't see any relationship between these tables.
Yes. We have the relationship, but we don't have a foreign key. So it is not quite understandable how category and customer.
Why do we have it at all?
Why do we have it, and how they are related to each other? Yeah, correct. And same with customers and products. So we have
maybe have to add
the relationship between customers and products, but I have no idea why do we have this relationship. Of course, customers should be related to orders, and orders should be related to products, not directly. Maybe it is possible to buy a product without an order, but I doubt in this fact.
And
maybe
probably we need a relation between products and shopping order.
Products and shopping order, yes.
shopping order and payment.
I guess. Yeah.
Oh, yeah.
Shopping order and payment. Yeah, this is logical. Yeah. So order should contain one to several products and some payment, some type of payment. Yeah, and maybe payments. Payments should be in a different table, of course, like payment log. But again, maybe. Yeah, sure.
So we talked about like tables, customers, categories, and products. So we discussed that some of them are necessary, some of them are not. So I have in my head like the examples. So for example, if I know what I'm looking for, I just type directly what I need. So I just type the precise product. But if I don't know what I want, I just go to the categories. So I think both of these connections between customers and categories and customers and products could be useful, like, no? Because it depends on
I think I have got your idea. Some popular categories or the categories that have seen by customers. Yes, can be, but anyway, we don't have a foreign key here. We don't have a foreign key customer ID in categories table, and we don't have category ID in customers table. So maybe that was a brilliant idea to connect to tables and to make some propositions to a customer based on his or her choice of categories, but how are they going to get the information? I don't know. This is like relationship, but without keys inside. Yeah. So another strange ER diagram.
Yeah.
Okay.
So and also should we maybe connect as we discussed, like customers to sellers? For example, if I know the seller specific, so I can just also connect like foreign keys between these two.
Maybe, but in this case, actually, this database should be more complicated, should be more complex, and should have more information, because this one looks very simple, and sellers are connected to products only. So yes, and the seller, why product ID is foreign key in the seller table? Because from my perspective, it will be better to have a seller ID in product table. Because again, we have, I think, I don't know, maybe one-to-many relationship here, one seller, different products, and a product could be sold by only one seller. I think maybe many-to-many, but anyway, the realization that we have here is weird. I don't know what this architecture meant. Sorry?
I thought about it about the connection between seller product too, and guys told me that maybe I don't know, like a few sellers sell carrots, I don't know, and a few. I missed the idea.
Yeah, I understand. I understand. So, for example, we have a lot of sellers that, for example, sell, I don't know, cucumbers, and we have a lot of cucumbers which are sold by different sellers. So it's many to many.
But if we are talking about a product, it is not an abstract cucumber, for example. It is like a particular product with a particular ID by a particular manufacturer. So we are not talking here typically. We are not talking here about some abstract objects. We have some particular thing.
Okay, so it's one to many.
One to many, yeah, rather one to many. Yes.
Okay.
There can be a problem with this approach, many to many. If we we don't know how to count from who we bought this, if who sold it, who's the money at the end.
Yes, absolutely right. So we should have some particular relationship, whom to pay for this product. Yes. Okay. Anything else?
Maybe in transaction report we need to add seller's ID.
Seller's ID, but we can know seller's ID by a product ID. So it is not mandatory to have it here.
Wrong.
Okay, guys. Talking about the bookstore, I think we could skip it for now because we have already 2 hours, almost 2 hours class today. I could put this picture of ER diagram to your homework as an additional thing. So if you liked this topic and you want to train more, please, you could see this diagram. And as for today's finishing of today's class, next time we will start the workshops about SQL, about SQL, 3 workshops in a line. I should again tell this add integration to the people who now watch us on the YouTube. Of course, this one and the next one will be the public lectures, and from next Monday we will have only private lectures till the end of the course, no more public things. But since we have public lecture now, again, you have just watched our professional approach to workshops. When we discuss everything together, when my personal motivation is to improve the quality of ID, and the same motivation all our mentors have, absolutely the same motivations, and the interests of our guys come before the interest of us as a school. All who are now here together, past the professional orientation and past all the tests that we have before entering the course, and we hope that we will have a high KPI of the school, because everybody who are here today, we hope that everybody will have a successful career, because our students 2.5 times more likely to create job than Yandex Practicum students, and 6 times more often than students of most major learning platforms. We still have some seats in the groups, in the current one and in the Russian-speaking group that will start in September 2023. And if you want to join us, please come to Mentorpiece Consult in Telegram, or follow the links that you see here and that will be under the video, and take our preliminary test, then professional guidance, placement test, and exam. That's all. We have checked the results. A bit about the homework that you will have after this class. You will have 2 homeworks, basic and advanced. The basic homework will be about comparing the objects in the UI and the database that we have for our educational application. It will be the exercise for you. This ability to map the objects to the database. You should use your knowledge about the relation, the ER diagram, and the types of data. And the advanced homework is very interesting, because you will play a role of database engineer. You will try to draw your own ER diagram of a library. So everything that we trained today will be applied to this advanced homework. And that's all. The homework will be in Moodle. We will see next time. And we will train some simple queries on SQL. Thank you, everybody, for today's class.
Thank you.
It was amazing.
Thank you.
It was very, very interesting.
Yeah.
Hope that for you as well. And see you next time, guys.
Yeah, thank you.
See ya.
Thank
Thank you.
you very
Bye.
much.
Thank you.
And bye.